in binomial distribution, what is the use of the binomial distribution and how we can solve the problem of the binomial distribution, we have learned in our last video. In today's video also, we will having some question related to the binomial distribution. In today's video, we will discuss the constant values of the binomial distribution. With the help of the binomial distribution, we can calculate arithmetic mean, we can calculate standard deviation, we can calculate variance, we can calculate first moment, second moment, third moment, fourth moment, kurtosis. So many constant value we can calculate with the help of the binomial distribution. So in today's video, we will learn how we can calculate constant value with the help of the binomial distribution. So the very first we will discuss the formula related to the constant value of binomial distribution. Suppose we are to calculate arithmetic mean with the help of binomial distribution, the formula will be NP. For calculating arithmetic mean, we will use the formula x bar is equal to NP. If we are to calculate standard deviation, so the standard deviation is NPQ, or variance, that is NPQ. So for calculating the constant value with the help of the binomial distribution, if we want to calculate arithmetic mean, then we will multiply number of items with the probability of items. If we want to calculate variance of this, then we will having the multiply number of item with the probability of occurrence of a item and non-probability of the occurrence of the item, that is NPQ. Similarly, with the help with the help of binomial distribution, we may be having some other related also, like moment coefficient of skewness, that is called under root beta 1, and for this, that is q minus p raised to power 2 divided by NPQ. The formula will be q minus p raised to power 2 divided by NPQ. And last one, measures of kurtosis is over there. If we are to calculate kurtosis, so that is called beta 2. For calculating kurtosis, that is beta 1 and this is beta 2. So the formula is for this 3 plus 1 minus 6 PQ divided by NPQ. So these are the formulas for calculating constant value with the help of the binomial distribution. We are having other moments of the skewness, moment first, moment second, moment third, moment fourth, but generally in question we didn't require this, so that's why I am not showing that what is the value of u1, what is the value of mu2, mu3, mu4, because these moments value we are not asking in the question, so that's why I am not explaining here. The questions which is asked in this related to the constant value of the binomial distribution, generally they want the arithmetic mean, they want the variance, they want the moments of moment coefficient of skewness, that is called beta 1, that is under q minus p raised to power 2 divided by NPQ. Sometimes they want the value of the kurtosis, that is 3 plus 1 minus 6 PQ divided by NPQ. So in this video we will learn the question related to the constant value of the binomial distribution. We will having 2 or 3 questions in this video. So this is the formula for the binomial distribution. Later we are having the one question, 8 coins tossed up to 256 times. Number of coin is 8 and tossed up to 256 times. Okay. The original result is for 0 head, for 1 head, for 2 head, for 3 head, for 4 head, for 5 head, for 6 head, for 7 head, for all head. The original frequency is 2630, 52, 67, 56, 32, 10 and 1, and this is 256. So the very first question of the binomial distribution is 8 coin tossed 256 times, and the result is that 0 hit 2 times, 1 hit 6 times, 2 hit 30 times, 3 hit 52 times, 4 hit 67 times, 5 hit 56 times, 6 hit 32 times, 7 hit 10 times, and 8 hit is 1 times. Now we are to calculate first one arithmetic mean of this, then standard deviation of this, then variance of this, and the moment skewness and kurtosis of this. So the very first arithmetic mean of this. So in coin, getting head is 1 by 2 and getting tail is 1 by 2. Okay. So we are having, this is original frequency, we have to calculate the estimated frequency. The very first we are to calculate the constant value of the binomial distribution. The very first I am calculating arithmetic mean. So arithmetic mean x bar is equal to np. So n is 8, 1 by 2 that is 4. So the value of x bar is 4. Second, if you are to calculate standard deviation, that is npq, that is 8 multiply 1 by 2 multiply 1 by 2. So that is under root 2. So getting the under root of 2, 1.141. If you want to calculate the variance of this, that is npq. So that is 8 multiply 1 by 2. N value is 8, p value is 1 by 2, q value is 1 by 2. So there will be 2. If we want to calculate other that is called moment coefficient of skewness. Moment coefficient of skewness, that is beta 1, q minus p raised to power 2 upon npq. The formula for the moment coefficient of the skewness, that is beta 1. The formula for that is q minus p raised to power 2 divided by npq. So we will write here 1 by 2 minus 1 by 2 raised to power 2 divided by npq, 8 multiply 1 by 2 multiply 1 by 2. So this will be converted to 0. So the moment coefficient of the skewness will be 0. But if we want the coefficient of kurtosis, so that will be 3 plus 1 minus 6 pq divided by npq. So this will be 3 plus 1 minus 6 multiply 1 by 2 multiply 1 by 2 divided by 8 multiply 1 by 2 multiply 1 by 2. So the value of this will be 3 plus 1 minus 6 upon 4. 6 divided by 4, that is 1.5. So 1 minus 1.5 divided by 2. So that will be 3 minus 0.5 divided by 2. 0.5 divided by 2 is minus value, 3 is plus value. So that will be 2.75. So this value will be 2.75. So with the help of this, we can calculate the various value related to the number of items. So the arithmetic mean of this will be 4. Standard deviation will be 1.141. Variance will be 2. The coefficient of skewness, moment coefficient of skewness will be 0, because 1 by 2 minus 1 by 2 0. So it converted all the 0. Then we have calculated the value of measures of kurtosis. So the kurtosis value is 2.75. So in this manner we can calculate the constant value related to the binomial distribution. Now if we are to calculate the estimated frequency for that. suppose we are to calculate the chi-square test between original frequency and estimated frequency. So this is the original frequency. We have tossed 8 coins up to 256 times. 2 times we get all head is over there. But here we are having n is equal to 8 and r is equal to 8. It means this is 0 head. 0 head is over there. So 0 head is over there. First one 0 head. And it means all tail, 2 times all tail, 1 times all head is over there. So this is number of head. Number of head. So probability of getting 0 head, that is 8C0, P raised to power 0, Q raised to power 8, and this happened up to 256 times. So that is 256 multiply 1 multiply 1 by 2 raised to power 0 multiply 1 by 2 raised to power 8. So 256 multiply 1 multiply 1 multiply 1 by 256, that is 1. So the estimated frequency for this is related to 1. Now n is equal to 8 and r is equal to 1 for one head, that 256 8C1 P raised to power 1 Q raised to power 7, 256 multiply by 8 multiply 1 by 2 raised to power 1 and 1 by 2 raised to power 7. So 256 multiply 8 multiply 100, 256. So the value will be 8. So second estimated frequency is 8. Third, if n is equal to 8 and r is equal to 2, then 256 8C2 here. Here the value of r is 2. So P raised to power 2, Q raised to power 6. So 256 multiply 8 multiply 7 upon 1 multiply 2. 1 by 2 raised to power 2, 1 by 2 raised to power 6. So we have a 256 multiply 28 multiply 100, 256. So the value is 28. So 3 value we have calculated. For getting 0 head, the expected frequency is 1. For getting 1 head, the expected frequency is 8. For getting 2 head in 8 coins, expected frequency is 28. If 8 coins tossed up to 256 times, there is a probability that in 28 times there will be 2 head. Similarly, we will calculate next one. If we are to calculate 3 head, so n is equal to 8, r is equal to 3. So 256 8C3 P raised to power 3 Q raised to power 5. So 256 multiply 8 multiply 7 multiply 6 multiply 1 multiply 2, 1, 2, 3, 1 by 2 raised to power 3 and 1 by 2 raised to power 5. So that will 256 multiply 56 multiply 1, 256. So that is 56. Here we are saving 1 by 2 raised to power 3 and 1 by 2 raised to power 5. So it converted to 1 by 2 raised to power 8. So 1 by 2 raised to power 8, that is 1 by 100 to 256. So 256 to 256 cancel. So 56 is over there. N is equal to 8 and r is equal to 4. Then 256 8C4 P raised to power 4 Q raised to power also 4. So 256 multiply 8 multiply 7 multiply 6 multiply 5 multiply 1 multiply 2 multiply 3 multiply 4, 2, 3 to 6, and this 2. 1 by 2 raised to power 4 and 1 by 2 raised to power 4. So 70, 256 multiply by 70 multiply by 100 to so that will be 70. So the frequency of this will be 70. N is equal to 8, R is equal to 5. So 256 8C5 P raised to 5 Q raised to power 5 minus 8 minus 5, that is 3. So 256 multiply 8 multiply 7 multiply 6, 1 multiply 2 multiply 3. So that is 56. Okay. we have to write for 3, that is 56, then 70, then also 56. 1 by 2 raised to power 5, 1 by 2 raised to power 3. So that is 256 multiply 56 multiply 100 to 56. So that will be 56. Next, n is equal to 8, r is equal to 6. So 256, 8c6, p raised to power 6, q raised to power 2. So 256 multiply 8 multiply 7 upon 1 multiply 2, 1 by 2 raised to power 6 and 1 by 2 raised to power 2. So that will be 256 multiply 28 multiply 1 upon 256. So that will be 28. So here 28. Similarly, 1, 8, 28, 56, then 70, then reverse 56, then 28. So it will be 8 and 1. N is equal to 8, R is equal to 7. So 256, 8c7, p raised to power 7, q raised to power 1. So 256 multiply 8 upon 1, 1 by 2 raised to power 7, 1 by 2 raised to power 1. So 256 multiply 8 multiply 1 upon 256. So the value will be 8. Similarly, last value will be 1. So with the help of binomial distribution, we can calculate arithmetic mean, we can calculate standard deviation, we can calculate variance, we can calculate the value of skewness, and we can calculate measures of kurtosis also. We can having measures of skewness and we can having measures of kurtosis also. If original frequency is given, estimated frequency we can calculate it, estimated frequency with the help of the binomial distribution. And if we are to calculate other tests like chi-square test, we can calculate with the help of this f0 minus fe. We can calculate if chi-square test is asked, then also no problem, we can calculate the value of chi-square test also, no problem at all in this. We are having one more question related to the constant value of the binomial distribution. Other second question we are having. A screw is the probability of manufacturing a defective screw is 1 by 10. It means a company is making the screw and the probability that out of 10, one screw have defective is over there. It means they have some problem in चूड़ी, I should say. यानी एक जो फैक्ट्री है वो पेच बनाती है, स्क्रू बनाती है, उस फैक्ट्री में 10 में से एक स्क्रू के खराब होने की संभावना है. यदि कंपनी 800 का पैकेट बनाती है, if company is company are having the packing in 800 screw in a box, so get the defective arithmetic mean of the defective screw, standard deviation, variance, measures of skewness and measures of kurtosis for that. So here n value is 800, p value is this and q value is 9 upon 10. So the arithmetic mean is equal to np. So that is 800 divided by 1 by 10. So the arithmetic mean will be 80. So the arithmetic mean value will be 80. If you are to want to calculate standard deviation, that is npq. So that is 800 multiply by 1 by 10 multiply by 9 by 10. So there will be 72. 10. So getting the under root of 72. 8.48. If we want to variance of this, that is npq. So that is 800 multiply by 1 by 10 multiply by 9 by 10. so that will 72. If we want measures of skewness, so the formula for that is q minus p raised to power 2 divided by npq. So that is 9 by 10 minus 1 by 10 raised to power 2 multiply by 800 1 by 10 multiply 9 by 10. So that is 8 by 10 raised to power 2 divided by 72. So we will having 60.64 upon 72 because 8 raised, so 0.0088. So the value will be 0.0088. How we have calculated? 8, that is 0.8 square is 0.64 divided by lower value is 72. So 0.64 divided by 0.72 we are having the value. So that is 0.0088. Okay. If we are want to calculate the measures of kurtosis, so for calculating this, the formula is 3 plus 1 minus 6 pq upon npq. So we will apply the formula for that, getting the value of kurtosis. So 3 plus 1 minus 6 multiply 1 by 10 multiply 9 by 10 divided by 800 multiply 1 by 10 multiply 9 by 10. So 3 plus 1 minus 54.54 0.54 divided by 72. So 3 plus 0.46 upon 72. 54 is over there, 1 minus 54. 0.46 divided by 72 plus 3. So 3.006. So value is this 3.006. So with the help of binomial distribution, we can calculate various constant value, like we can calculate arithmetic mean, we can calculate standard deviation, we can calculate variance, we can calculate measures of skewness, and last we can calculate measures of kurtosis with the help of this. So I think this video will be helpful for you to learn how we can calculate the constant value with the help of the binomial distribution. In our next video, we will having some more question related to the same topic. Thank you once again.